Welcome. In this video, we will learn about clustering data for unsupervised learning techniques. Clustering is one of the most popular unsupervised learning technique. This technique is used to analyze data and find clusters within that data. In order to find this cluster, we use some kind of similarity measure such as Euclidean distance to find subgroup. This similarity measure can estimate the tightness of a cluster. When I will show you the output of a program, you will get idea about what is cluster. So first, let's open my directory and I have my files here. Let's open my text file which contain the random input data. So these are the coordinates, that is x and y coordinate of clusters. So here is my actual script, that is k-means.py. So basically in this video, we'll do clustering data with k-means algorithm. First, let's go to the output. Let's open terminal and run the command as python space k-means.py. So the first figure which come out is the input data. Here you can see the black and white input data of these all clusters. So this is what data we had given in text file. You can see a cluster, and here are the boundaries of cluster, that is output. So the black filled circle at the center of each cluster represent the centroid of that cluster. So the clusters are divided into 5 subgroup here with 5 different colors, and it has centroid. So this one is done with unsupervised learning with the help of k-means algorithm. I hope you got clear idea about what is cluster and what unsupervised learning did to the input of data, that is, it made 5 subgroup in the clusters. Now let's see the algorithm of this unsupervised learning, that is k-means algorithm. First one is import numpy as np, which we had already discussed for what this stands. After that, import matplotlib. This also we had discussed. The next one is from sklearn.cluster import k-means. From sklearn import metrics. So this one is new for us. So sklearn is a Python machine learning library. In that, we are specifically choosing cluster. And here import k-means, importing the algorithm of k-means. The k-means algorithm is known for this cluster purpose only. Now load the input data from the file and define the cluster. Here are 5 cluster. So x is equal to np load txt data clustering.txt delimiter, and here number of cluster equals to 5. Now visualize the input data to see what the spread looks like. That is, when you saw the output of this program, you saw the first diagram scheme was of the input data. So here the visualization of that input data will be created here. That is plot figure, plot scatter, and so on to plot y-trace. So this complete paragraph of data visualizes what the spread looks like and gives output as input data. Now we can usually see that there are 5 groups within this data. Now let's create the k-means object using the initialization parameter. The init parameter represents the method of initialization to select the initial centers of cluster. Instead of selecting them randomly, we use k-means to select the center in a smarter way. This ensures that the algorithm converges quickly. The nCluster parameter refers to the number of clusters, which we had declared as 5. So k-means equals to k-means, init equals to k-means and so on. Now train the k-means model with input data. So k-means.fit x. To visualize the boundaries, we need to create a grid of points and evaluate the model on all those points. Let's define the step size of the grid, that is step size equals 0.01. Now we define the grid of points and ensure that we are covering all the values in our input data, that is x minimum, x max, and so on. These 3 lines or 4 lines, we define the grid of points and ensure that we are covering all the values in our input data. Now predict the output for all the points on the grid using the trained k-means model. That is output equals to k-means.predict np.c x values revel y values. Basically, we are predicting the output for all the points on the grid using trained k-means model. So the k-means algorithm is already in the library of Python, which we had imported at beginning of this code. Now plot all the output values and color each region. That is output equals to output reshape x values dot shape plot dot figure plot dot clf plot show and so on. This will plot all output values and color each region. We are almost at the end of this code. Now overlay input data points on top of this colored region. So plot.scatter marker equals to O, face colors equals to none, edge color equals to black, S equals to 80. So basically overlay input data points on top of this colored region. Plot the centers of the cluster obtained using k-means algorithm. In the output you saw it had one black colored circle for each divided group. So this code, that is cluster center equals to k-means cluster center plot white tricks. This whole paragraph code will plot the center of the cluster obtained using k-means algorithm. Now show the screenshot of the plotting, that is plot.show. The code is complete. Anyhow, it was pretty much lengthy, but I tried my best to explain it in the brief. If you didn't get idea what stand for what, please do rewatch it again. Now let's move to the output now. Open the terminal and run the command python space k-means.py. The first screenshot shows the input data and the second gives the output, that is the black filled circle at the center of each cluster represents the center of that cluster. Here my details are displaying the cluster of 5 and the input object are defined. So what we saw in this video is most popular unsupervised learning technique of clustering with the help of k-means algorithm. So that's it. I hope you learned something of this video. Thank you for watching this video.